this question. So this is a differentiation from first principles question. And I know a lot of you see that and just hate it and don't want to do it. But it's 5 marks, and I don't think it's very difficult 5 marks to get. You just have to practice using the differentiation by first principles formulae. And it is a case of just bunging it in and then making h equal 0 at the end. That's all you need to do. So let's think. It's basically asking us, so it says a curve's got the equation 4y is equals 4x squared minus 5x, and it passed through the point 26. Use differentiation from first principles to find the value of the gradient of the curve. So basically, we want to find what dy by dx is and put x's to it. So we already know what we should get out of that because we can differentiate that, but that's not what it's asking us to do. But let's figure out what we know we should be ending up with. We should be ending up with 8x minus 5, shouldn't we, if we do our typical differentiation. But we need to prove you get that using differentiation from first principles. So you are given this in the formula book. You do not have to remember this. So it looks like this. So the first derivative of f of x as h tends to 0, so limit when h tends to 0, it's f of x plus h. So remember, this is basically the formula. It's changing y of changing x, where we're basically saying that we're changing we're changing the value of x. We're moving it a little bit along, and then we basically say as h tends to 0, we get rid of all the h's at the end. So that is the differentiation from first principles formulae. So remember that f of x here is, so it's 4x squared minus 5x. So we do f of x plus h. Everywhere we've got an x, we now write x plus h. So I'm just going to write here, so f dash x equals lim h tends to 0, and then we'll do, so it's going to be 4x plus h squared. So wherever there's an x, you replace it with x squared plus h for f of x plus h, minus 5x plus h minus then f of x, which is just 4x squared minus 5x. And that will all be over h. So that's the first step. Then we just need to expand all that lovely thing out. So I'm just going to keep going here. So we end up here with, it's going to be 4 lots of x squared, and then we're going to end up with 2xh there plus h squared minus 5x minus 5h. And then be careful, I really should put that in brackets because remember it's minus all of f of x. So that'll be minus 4x squared, and then it'll be a plus 5x. So just be careful of that. Sorry, I'm going to slightly run out of space. Let me just squidge along there. Like so. So it's that all over h. And then that's all going to be multiplied by 4, isn't it? So yeah, I know it's quite a long thing to write out over and over again, but if we do it like this and we don't rush, we're far less likely to make mistakes. We end up here with 4x squared plus 8xh plus 4h squared even. And then the rest of it. So minus 5x minus 5h minus 4x squared plus 5x. Like so, all over h. So then we can now cancel some things out here, can't we? So we have a 4x squared and we have a minus 4x squared. So they cancel. We have a minus 5x and a plus 5x. So they're going to cancel. And then let's think about, we also have h's here. So let's use purple for that. So the h's, so we can cancel a h there, h there, and h there because we're dividing everything through by h. So now let's think about what we are now left with. So we have now, so when h tends to 0, that limit there, we have 8x plus 4h minus 5. I remember all of that, because remember we're saying that all of that is equal to the first derivative of x, or dy by dx. So when we say that, so we're saying as h tends to 0, so as h tends to 0, 4h would also tend to 0. So therefore, this thing here, that will become, let me just zoom out a little bit. That will therefore become then just 8x minus 5. And that's what we wanted. So first derivative of x, dy by dx, that thing there is 8x plus 4h minus 5, but we know it's h tends to 0, 4h tends to 0, so therefore we're just left with 8x minus 5. So now that's the tricky bit. Now let's do the simple bit. So we wanted to know from all that, we wanted to know the gradient at 2, 6. So we want to know what dy by dx is at 2, 6. So that means we just put x as 2 in, don't we? So we now know dy by dx is 8x minus 5. So 8 lots of 2 minus 5. And this bit I'm sure we can do now. So 16 minus 5, it would give us 11. So therefore the gradients, let's just check we've actually answered our question. So the value of the gradient on curve P, so therefore, yeah, we can just write, if you want to be extra short, m is 11.